Welcome to the Explainer. Okay, let's jump right into this because we have a lot of ground to cover. Months down to mere hours. That is literally how fast frontier AI models are compressing the timeline between finding a vulnerability and actually exploiting it. We are in the middle of a massive, urgent shift in cybersecurity right now. We're having to completely move away from traditional perimeter security because, let's face it, it just can't keep up anymore, and transition to a strict zero-trust architecture that's specifically built for autonomous AI agents. So the big question is, how on earth do we protect systems that are designed to act entirely on their own? Well, today we're exploring agent security within 3 tiers to figure out exactly how to build, deploy, and most importantly, secure these incredibly powerful tools. Here is our roadmap for today. We'll start with building autonomous agents. Then we'll look at the agentic threat landscape, followed by zero trust for AI. Then we'll break down the tiers. Tier 1, foundation security, and the enterprise and advanced tiers. And finally, we'll wrap up with defense at machine speed. All right, section 1, building autonomous AI agents and the sheer power of autonomy. Picture this for a second. You are building a no-code workflow to give an AI access to a company's proprietary knowledge base using a retrieval augmented generation, or RAG system. It's super smooth. You pull the data directly from Google Sheets, run it right through OpenAI to create vector embeddings, upsert those unique numerical representations into a Pinecone vector database, and then bam, you use that retrieved context to generate highly personalized AI output. It is incredibly efficient, right? But think about why this actually matters from a security standpoint. This AI system is autonomously reaching into your proprietary data, transforming it, and making decisions based on it, with absolutely zero human oversight. And to give these agents even more operational juice, platforms like Make.com utilize something called custom functions. These are JavaScript-based operations that let agents transform data on the fly. But check out this fascinating constraint. A single custom function cannot run for more than 300 milliseconds. Just think about the implications of that kind of blistering speed. At 300 milliseconds, having human oversight isn't just difficult, it is physically impossible. These autonomous systems are executing complex, multi-step operations in literal fractions of a second, entirely unsupervised. Which brings us to section 2, the agentic threat landscape, the architect's dilemma. Let's compare traditional software with agentic AI for a minute. Traditional software executes predefined logic, right? It has strict, very predictable boundaries. But agentic AI executes multi-step operations with varying degrees of autonomy. It can interpret goals, it can select its own tools, and this introduces a massive headache called unscoped privilege. Honestly, it's a lot like handing a brand new intern the CEO's corporate credit card with absolutely no spending limit and just telling them, hey, go fix the supply chain. The agent is technically using legitimate permissions, but it can string them together in totally unpredictable or even malicious ways that traditional perimeter defenses simply cannot catch. So what does this actually look like in the wild? Consider the specific threats identified by OWASP for agentic systems. Take RAG poisoning, for example. If an attacker manages to introduce malicious data into your Pinecone vector database, the agent pulls that contaminated context and executes targeted payloads, totally believing it's legitimate data. Or think about tool chaining. An attacker could actually trick your agent into chaining a secure internal CRM tool with an external Make.com custom email function to secretly exfiltrate your customer data. And because those commands are executing through trusted tools under valid credentials, your traditional host-centric monitoring is completely blind to it. It sees absolutely no malware whatsoever. Okay, prepare yourselves for a truly shocking number. 250. According to Anthropic's research, it only takes injecting 250 malicious documents into a training set to permanently backdoor a large language model. 250. And the craziest part, those backdoors persist even through rigorous safety training. That just goes to show how rapidly and efficiently an AI-accelerated offense can completely compromise your entire system. Let's look at the solution in section 3, Zero Trust for AI, a new security paradigm. Here is the core philosophy, and it's a big shift. You have to abandon the idea of a secure perimeter. Trust absolutely nothing, verify everything, and operate under the assumption that a breach has already occurred. You really have to start treating your internal corporate network as if it's already a completely hostile environment. A request originating from safely inside your firewall, it has to receive the exact same level of aggressive scrutiny as a random request coming from an unknown external IP address. No exceptions. I want you to basically burn this quote into your brain whenever you evaluate a new security control. Does this make the attack impossible or just tedious? Because agentic attackers, they have unlimited patience and a near zero cost per attempt. Rate limits, non-standard ports, SMS-based multi-factor authentication, those are just friction-based defenses. They just make things tedious, and against an AI, friction always fails. You absolutely need controls that remove a capability entirely, creating a hard mathematical barrier. So how do we build that? Section 4, Tier 1, Foundation Security, the new baseline. To achieve true zero trust across 3 tiers, your security controls have to aggressively mature. Notice how identity has to move from basic cryptographic IDs at the foundation level all the way up to hardware-backed credentials. Privilege scales from static role-based access control all the way up to dynamic just-in-time access. And isolation? It moves from basic network boundaries to highly secure confidential virtual machines. The biggest takeaway for this foundation tier is that it simply no longer accepts static API keys. If your system is relying on static API keys that could easily be scraped from a config file, you don't even meet the foundation baseline. This tier strictly demands short-lived tokens with automatic refresh, uniquely assigned cryptographic identifiers for every single agent instance, incredibly strict role-based access control, and network segmentation that acts purely as a backstop, definitely not your primary boundary. Section 5. Enterprise and Advanced Tiers, Scaling Defense. Once we step up to the enterprise level, you absolutely must have sandboxed execution environments per agent. If an agent is out there processing web content or any untrusted input, a sandbox contains the blast radius. So if that agent gets compromised, it's effectively trapped inside a useless void rather than freely roaming around your internal network. And at the advanced level, we introduce this concept of least agency via just-in-time, or JIT, access. This means an agent is granted permissions only at the exact millisecond of need, specifically scoped to exact resources for a specific duration, and then automatically revoked the second the task is complete. Absolutely no standing access persists. Now, I've got a really tough question for you to chew on. Would you know within an hour if an agent went rogue in your estate? Really think about your dwell time, that critical window between an anomaly happening and a human actually realizing it. Manual tracking is just completely obsolete against machine speed attacks. If you aren't logging trace IDs, tracking agent identities, and keeping immutable audit trails, I guarantee the answer to this question is no. Which leads us to our final section, Section 6, Defense at Machine Speed, Automated Response. Let's ground this whole concept with a really brilliant real-world automation feature, Make's Retry Error Handler. When a scenario hits a temporary error, say a database connection fails, this handler essentially acts as a circuit breaker. Instead of letting the entire system crash and burn, it pulls that failing bundle right out of the flow, stores the error context, and enables automated retries based on your exact settings, all while the rest of the system just keeps right on processing. Remember that 300 millisecond speed constraint we talked about earlier? At those breakneck speeds, an automated circuit breaker is quite literally the only defense that stands a chance. Our defenses have to automatically pause operations, isolate anomalies, and recover without total system failure. You see, operating at machine speed means we have to automate the bookkeeping, not the final decision. First, a triage agent automatically flags the anomaly. Second, the system immediately executes automatic containment, doing things like terminating the agent session or revoking credentials instantly. Third, agentic SOAR playbooks orchestrate the response, aggressively scooping up all the forensic data. And finally, a human operator steps in to review the contained threat and make those critical disclosure or remediation decisions. Human decision speed during an incident should absolutely never be rate limited by manual evidence collection. As we wrap up this explainer, I want to leave you with one final provocative thought to take back to your team. Are your agent deployments architected for breach from day one? Because the organizations that are going to survive this massive technological shift aren't necessarily the ones with the flashiest, most advanced AI. They are the ones whose fundamentals are deeply, solidly built on zero trust principles. It's time to take a hard look at your systems, kill off those static API keys, and genuinely assume the breach has already happened. Thank you so much for joining me for this deep dive into agent security.